If you like our videos and it's useful to you, do subscribe to the channel. In this video, we will look in Cath Lab, also known as interventional heart catheterization. Let's begin with the introduction to Cath Lab machines. Cardiac catheterization was first performed when Werner Forssmann, in 1929, created an incision in one of his left antecubital veins and inserted a catheter into his venous system. He then guided the catheter by fluoroscopy into his right atrium. Subsequently, he walked up a flight of stairs to the radiology department and documented the procedure by having a chest röntgenogram performed. Over the next year, catheters were placed in a similar manner into the right ventricle, and measurements of pressure and cardiac output using the Fick principle were performed. Most catheterization laboratories are single-plane facilities, those that have a single X-ray generator source and a single X-ray image intensifier for fluoroscopic imaging. Older cath labs used cinefilm to record the information obtained, but since 2000, most new facilities are digital. The latest digital cath labs are biplane and have 2 X-ray sources and use flat panel detectors. Let's look into the procedure of cardiac catheterization. Procedures in the cardiac catheterization field are primarily concentrated on the study and treatment of the heart chambers, coronary arteries, and other proximal vasculature. Categories in this field may include cath labs, radiographic fluoroscopic units, digital vascular imaging systems, angiography units, cardiac catheterization equipment, and cardiac systems. When using a cath lab for angiography, recommendations and preferences refer to peripheral and abdominal vasculature cases. All 3 types of systems, cardiac catheterization equipment, general angiography units, and multipurpose systems, have different requirements regarding the C-arm assembly, image acquisition detector, image processor, and patient table characteristics. Cardiac catheterization is an invasive procedure involving inserting a catheter into a blood vessel in the arm or leg and guiding it to the heart with the aid of a special X-ray machine. Contrast media is injected through the catheter so that X-ray movies of valves, coronary arteries, and heart chambers are taken. Let's know about the components of cath lab. The C-arm, or U-arm, which is the largest and heaviest cath lab part. It is either a floor-mounted or ceiling-suspended arc which carries the X-ray tube and the detector. The X-ray tube is the cath lab part which generates the powerful X-ray pulses in the cinemode. It should be a heavy-duty tube with high heat capacity and improved heat dissipation. A good cooling system is essential. The X-ray detecting device is the most sophisticated and yet the most delicate cath lab part. In older cath lab systems, an image intensifier is used, but in newer models, a flat panel detector is the modern cath lab part which replaces the image intensifier. The generator is the high-voltage, high-power source cath lab part instrumental in energizing the X-ray tube. It should be compatible with the X-ray tube and capable of delivering the full current capacity of the X-ray tube in cinemode. The collimation system, another integral cath lab part, helps to shape the beam of radiation emerging from the machine, limiting the maximum field size of a beam, therefore reducing radiation exposure to the patient. The X-ray switching and pulse controller is a cath lab part which sets the X-ray generator in on-off sequence, both in the fluoroscope and the cinemodes. A specialized digital image processor with program selector is an important cath lab part that can contribute a lot to the diagnostic value of the cine recording and the fluoroscopic imaging. Other significant cath lab parts include patient table, operating console, cath lab monitors, patient skin dose logging system, physiological monitoring system, automatic injector, and in larger installations, biplane X-ray systems. Also, the ability to connect the cath lab system to medical data lines into the hospital mass data storage, PACS, and information system should be carefully examined. Let's know about C-arm X-ray machine work. Mobile fluoroscopic system, also known as portable or mobile C-arm, comprises a generator, X-ray source, and an image intensifier or flat panel detector. The C-shaped connecting element allows movement horizontally, vertically, and around the swivel axis so that the X-ray images of the patient are produced from almost any angle. The generator emits X-rays that penetrate the patient's body. The image intensifier or detector converts the X-rays into a visible image displayed on the C-arm monitor. The physician can check anatomical details such as bones and the position of implants and instruments at any time. This was the introduction video on cath lab and C-arm machine. In the next video, we will discuss about flat panel detectors, image intensifier, automatic injector, patient skin dose logging system, biplane X-ray systems,